Okay, so let's discuss parallel and perpendicular lines. So these are concepts that you should remember from back when you took geometry. The proof of these is a little bit beyond the scope of this class, but I think that we can look at a couple of examples and kind of understand how it works. Okay, so looking at two parallel lines, remember that that means that they lie in the same plane, but they don't intersect. Okay, they always stay, so that means they always stay the same distance apart. So we've got two parallel lines right here, red and blue. And if we look at the slope for these, okay, pick a couple points that you can tell, we see that we're going to go up to and over 1. Okay, so the slope for the blue line is going to be 2 over 1, which is 2. Okay, now if you look at the red line, it's got to do the same thing to stay the same distance apart. If it didn't do the same thing, it would be at a different angle and eventually they would intersect. So it's going to have to do the same exact thing, the same exact spacing, up to over 1. So the slope for this one is also 2 over 1 is 2. So this is just one example, but parallel lines always have the same slope. Okay, so sometimes we say M1 equals M2. Okay, the slope for one is the same as the slope for the other. Okay, now perpendicular lines is a little bit harder to see, but hopefully this example helps. All right, the slope for one, so let's look at the blue line first. Remember, perpendicular lines meet at a 90-degree angle. Okay, so that's what we have right here. The slope for one, okay, let's go down 1, right 2. Okay, so down 1, right 2. So the slope for this one is down 1, right 2. The slope is negative 1/2. And the other one is the red line. It's the same as the one that we had before. So it's going to go up to right 1. Okay, so the slope for this one is negative 1/2, and the slope for this one is positive 2. And that's always going to be the case in order to get them to meet at 90-degree angles. We've got to have this distance has got to be reversed. Okay, so for perpendicular lines, we can say that the slopes are negative reciprocals. So basically the x and y have to reverse, and one of them is going to have to be negative. So slopes are negative reciprocals. So they have opposite signs, and they're reciprocals of each other. And sometimes we write that as m1 equals negative 1 over m2. So change the sign and flip it. To get from one to the other, change the sign and flip it. Okay, so now let's use this together with what we worked on with the equation of lines. Okay, so let's say that we have a line passing through the point, let's do negative 1, 4, with slope, oh, sorry. That's not what I want to say. Okay, we want to be parallel to the line y equals 3x minus 6. Okay, so our line is going to pass through this point that we're given, and we need it to be parallel to this other line. Okay, so remember, parallel means same slope. So we need our line to have the same slope as this line. This line is in slope-intercept form, and so the slope is right here. Y equals mx plus b. The slope is m. Okay, so our line is going to have slope 3, and it's also got point negative 1, 4. So slope and point, we should be able to find the equation of our line. We don't need this line for anything anymore. We just use that to get the slope. We're going to use our slope and our point. Okay, so you can remember we talked about the two different forms of the equation. I'm going to go ahead and use y equals mx plus b, but you can use the point slope version as well. That's fine. Okay, so I'm going to put in the m. Okay, so the equation looks like this. I'm going to put in the point as my x and y so I can find b. So 4 equals 3 times negative 1 plus b. So that's going to be negative 3 plus b. So I'm going to add 3 to both sides, add 3 to both sides, and I get 7 equals b. So now I have m and I have b, and my equation is y is equal to 3x plus 7. Okay? And you can double check, they have the same slope, so we're in good shape. Okay, let's say that we want to find the equation of the line passing through. Let's do 4, negative 2, perpendicular to the line y equals 2/3 x plus 4. Okay, so we have a point. We need a point and a slope to make the equation of the line. We don't have the slope, but we do know that it's perpendicular to this line. Okay, so what's the equation of the line that what's the slope of the line that we're given? Okay, it's in y equals mx plus b form, so the slope is 2/3. Okay, that's the equation of this line. Our slope, we need it to be perpendicular to this, so we're going to change the sign and flip it. Okay, change the sign and flip it. Our slope is going to be negative 3/2, and our point is going to be 4, negative 2. Okay, so we use this equation of the line to get that slope. We want our slope to be perpendicular, so we're going to change the sign and flip it. Okay, so we've got m equals negative 3/2, and we've got our point 4, negative 2. Okay, so y equals mx plus b. I'm going to put that slope in. Okay, I need to find b, so I'm going to put in the point, xy. So I've got negative 2 equals negative 3/2 times 4 plus b. Okay, and remember this is like 4 over 1. We multiply, so we're going to get negative 12 over 2. Negative 12 over 2 would be negative 6. And then we want to get b by itself. So we're going to add 6 to both sides, and we're going to get 4. Okay, so the equation of our line is y is equal to negative 3/2 x plus 4. Oh, and that's kind of funny. They both have the same y-intercept. That's a total coincidence. I just made this up, and they actually have the same y-intercept. So that's pretty funny. Okay, so remember, if they're parallel, it's going to be the same slope. You see that right here. Parallel means same slope, and perpendicular means negative reciprocal.